Hi friends, my name is Ishan Gada Ishwar. I am studying in 77 Engineering College. Uh, Today my USN is 180 CS 189. Topic two-way ANOVA. Delving into two-way ANOVA, this presentation delves into the intricacies of two-way ANOVA, a statistical method used to analyze the effects of multiple independent variables on a dependent variable. We will explore the core concept and assumptions and applications of these power tools. What is two-way ANOVA? Two-way ANOVA is a statistical technique that examines the impact of two independent variables on a dependent variable. It assesses the individual effects of each variable and their combined effect. Example: examine how fertilizer factor 1 and watering frequency factor 2 affect plant growth. Dependent variable. A two-way ANOVA analysis of variance is a statistical test that analyzes how two categories independent variable affect a continuous dependent variable. It's used to estimate how the mean of quantitative variable changes based on the levels of the two categorical variable. The two-way ANOVA is similar to one-way ANOVA, but it's used when comparing groups on two different categorical variables. The main difference between two is that two-way ANOVA interrupts both main effects and the interaction effect. A two-way ANOVA determines whether the variability of the outcomes is due to the chance or factor in the analysis. It's a key statistical test in many research fields, including finance, economics, biology, and psychology. A two-way ANOVA can be used to determine if two independent variables in combination affect dependent variable. For example, you might want to know if your gender and level of education have an influence on salary. A repeated measures two-way ANOVA means that one of the factors was repeated. For example, you might compare two treatments and measure each subject at four time points. Assumption of two-way ANOVA. Normality: the data for each group should follow a normal distribution. Homogeneity of variance: the variance of the dependent variable should be equal across all groups. Independence: observations within each group must be independent of each other. Experimental design. Hmm. Define factors, identify the independent variables that will be manipulated, set levels, establish the specific values or conditions of each factor. Random assignments randomly assign participants or units to different combinations of factor levels. Randomness and level experiments law crystal the factor plus 1 43 9 plus 7 24 2 plus 2 25 30 plus 30 35 5. Main factors, the main effects: factor 1, factor 2. Interaction effects. um, the effect of factor 1 may vary depending on the factor 2. Factor 2, the effect of factor 2 may vary depending on the level of factor 1. Interpreting main effects. A significant main effect indicates that the factor has noticeable impact on the dependent variables. Non-significant or non-significant main effect suggests that the factor doesn't have a notable effect on the dependent variable. In this table, you will know about the table and the backlight. Mm. And ANOVA is a statistical test used to analyze the difference between the means or more than two groups. Example: you are researching which type of fertilizer and the planting density produces the greatest crop yield in field experiment. You assign different plots in a field to combination of a fertilizer type uh, and measure the final crop yield in bushels per acre at harvest time. Bushel per acre is a quantitative variable because it represents the amount of crop produced. It can be divided to find the average bushels per acre. A categorical variable represents types or categories of things. A level is an individual category with categorical variable. Fertilizer types 1, 2, 3 are levels within the categorical variable fertilizer type. Planting densities 1 and 2 are levels within the categorical variable planting density. You should have enough observations in your data set to be able to find the mean of quantitative dependent variable at each combination of levels of the independent variable. Both of you independent variables should be categorical. If one of your independent variables is categorical and one is quantitative, use an ANOVA instead. Interpreting interaction effects. Significant interaction. The effect of one factor depends on the level of another factor. Non-significant interaction. The effects of factors are independent of each other. Example, you can see the graph. The first one is dependent on other graph, and the second one is it's independent of each other. Cost or test. YT now the table that is it defines the values and pairwise comparisons. Post hoc tests helps determine which specific groups differ from each other when there is all overall significant effect. Practical applications in experimental design, practical applications, and interpreting result. Conclusion of the key takeaways. Impact assessment. Two-way ANOVA enables researchers to assess the impact of multiple factors on dependent variables, considering both individual and combined effects. Decision making to finding the findings of from two-way ANOVA can inform decisions about the factors that are most important and how the outcomes come. Thank you.